Hi. So in today's second question is regarding our delta connection. Okay. So the question is calculate phase and line currents and load impedance parameters in a balanced delta connected load which consumes a power. So what are the given values? The given values are it consumes a power. So power consumption is equal to 25 kilowatt. So can you just tell me what is the equation? That will be equal to root 3 VL IL cos phi, and they have given cos phi is equal to 0.866, isn't it? And the supply voltage, line voltage, they have given us 400 volt, and the frequency they have given us 50 hertz supply. Okay, so we will proceed doing it. Okay, if you want, you can just pause the video and you can try it by yourself, and I will be solving the question. Okay, so let me take the calculator first. Yes, so we were given power. Now what we have to find out is we have to find out the line current, phase current. Okay, not equal to, okay, line current, phase current, and Z phase impedance load parameters. So the power they have given us 25 kilowatts. So 25 into 10 to the power 3, because we have to convert it into SI system. 25 into 10 to the power 3 is equal to root 3 into VL is 400, isn't it? Into IL, we don't know the value, and the cos phi, you know it is 0.466. From this we can say IL is equal to 25,000 divided by root 3 into 400 into 0.866. Current I got it as 41.667. 41.667 ampere. And what about the phase current? What is the relation of the line current and phase current as far as a delta connection is concerned? Okay, so can you just give me the equation for line, for the relation for line current and phase current? For yes, I forgot to summarize the equation first. um, for star connection, IL will be equal to I phase and VL will be equal to root 3 V phase. But here for delta connection, we know IL is equal to root 3 I phase, isn't it? So what is I phase? I phase is equal to IL by root 3. So what will be IL by root 3? That will be 41.667 divided by root 3. Okay. So this divided by root 3 will give you IL, that is 24 ampere. I phase will be equal to 24 ampere. Now if you want to find out the load impedance parameters, that is Z phase, they are saying it is a balanced delta load. So each phase will be having the same load. So Z phase will be equal to V phase by I phase. So what is V phase? For a delta connection, line value and phase value are equal. So V phase will be equal to 400 divided by the present answer, that will be 16.62 ohm. That will be 16.62. It is 16, okay, 16.62 ohm. This is the answer. I think I have just roughly done it. You can check whether any mistake is there, and that's it. Okay, so here Z phase is equal to, do I have to write the equation again? See, we have to find out, we have V phase equal to VL for a delta connection load, that is equal to 400 volt, and we have IL is equal to root 3 I phase. Okay, so we got the value of IL and I phase. I phase was calculated by IL by root 3, and we have I phase and V phase, so we can find out Z phase. Z phase is equal to V phase by I phase. So that is equal to 400 divided by what was our I phase, and you will get 16.6272 ohm. Okay, so I forgot what was the I phase. We'll go back. The I phase was 25. Okay, 24, and you will get this answer. Okay, I hope you understood. So I think this was a very easy question for you. Also, they were asking to find out the load impedance parameters. Okay, so they are saying 0.86 power factor lag. A power factor is 0.866 lag. That means the circuit will be an RL circuit, isn't it? Resistor and inductive load will be there. So now also we have to find out the uh, impedance parameters. So what all things we have to find out? Yes, the impedance parameters are R phase and J XL phase. Like that we have to find out. How can you find out? That is Z phase is equal to R phase J XL phase. So what is R phase? R phase is equal to Z phase into cos phi, isn't it? Do you remember all those equations? The same equation I have given in the last lecture also. I hope you remember all those things. Okay, so R phase is equal to, what is R phase? R phase is equal to Z phase into cos phi, and what is this X phase? X phase will be equal to Z phase into uh, sine phase, sine phi. Okay, like that we have to find out. Okay, so please do it. That is R phase equal to Z phase into cos. XL phase is equal to Z phase into sine phi. So what is Z phase into cos phi? So we have to find out what is Z phase. It was 16.62. 16.62 into 0.866. I think you were by hearting the value of 0.866. So that will be 14.39. Okay. So R phase will be 14.39 ohm, and what will be XL phase? That is again 16.62 into 16.62 into sine of cos inverse of 0.866. I have to take cos inverse. Okay, so I'm finding out cos inverse of 0.866. That will be 8.310. That is equal to 8.310 ohm. This is also ohm. So you have found out the impedance parameter as well as the uh, reactance parameter. So resistance and the reactance parameter. Okay, so you have found out the impedance parameters, that is the value for R and X. R and X. Okay, so that is it. And next we will be doing one more problem. Before doing it, we can find out this X phase, like Z phase is equal to root of R phase square plus X phase square. So we can also find out X phase is equal to root of Z phase square minus R phase square. You can use this equation also if you don't want to use this cos inverse and all those things. Okay. So now I just want to do one more problem. That is, see the question. The three-phase load consumes 100 kilowatt and 50 kVAR. It consumes 100 kilowatt and 50 kVAR. Determine the apparent power and the power factor angle. We have to find out power factor angle phi, not power factor cos phi. Okay, so this also we have to find out. Okay, so please pause the video and try to do it. Try to do it as early as possible so that it will be easy. We can increase our speed also. Okay. I hope you have done the question. That is, in the question they have given active power is equal to 100 kilowatt. That is equal to root 3 VL IL cos phi, and the reactive power they have given us 50 kVAR. So that is equal to root 3 VL IL sin phi. Okay. So we have to find out the apparent power and the power factor. Okay. So how can we find out the apparent power and power factor? So we need only root 3 VLIL. We don't need any sin phi or cos phi. So we can say apparent power S is equal to root of P square plus Q square, isn't it? So that is equal to 100 kilo square plus 50 kilo square and the root. Okay, and that will give you the apparent power. Let me check what is the apparent power. That is root of 100 okay, root of 100 kilo square plus 50 square. And I think we have to, it is better to give a bracket. So that is equal to what I got as 111.803 kVA. Then that will be kVA, 111.3 kVA. Then in order to find out the power factor angle, we can find out cos phi. What is cos phi is equal to P by S, isn't it? Check it. Root 3 VL IL cos phi divided by root 3 VL IL. Very easy, isn't it? So what is P value? P value is we got it as 100 divided by 100k divided by 111.803. K means this k and k will cancel. So 100 divided by answer, that will be 0.89. Okay, so that is 0.894. We have to find out cos inverse of this answer. Cos inverse of answer will be 26.56. Okay, so what is phi? Phi is equal to cos inverse of the 0.894, that is equal to 26.56 degree. Okay, that is the power factor angle. I have just used the active, reactive and apparent power. I have just used this power triangle. What is this power triangle? Power triangle says if this is reactive power, this is active power, and this will be apparent power. So that will be equal to power means VI cos phi, and here is VI sin phi, and this is the apparent power. So we can say apparent power is equal to root of P square plus Q square. I hope you understood, isn't it? So I am winding up this section with the two questions only. So you just go through it, and if you have any doubts, then you can ask me. Okay, thank you. Good night.